This should be a pretty concise video, and it probably should have just been included in the data representation video, but whatever. So, big endian, little endian, something that most people probably never have to deal with. But say you did have to deal with it. What is it and how does it work? Well, big endian and little endian are just different forms of byte ordering, and you may or may not already know that. Endianness itself just refers to how multi-byte values are stored in memory. It doesn't change the ordering of bits, and it doesn't change the order of unrelated bytes in separate values. Big endian is probably the way you think it should be ordered based on the way most people read numbers. The high order bytes are first and the low order bytes are last. So a quick demonstration, imagine you have this 64-bit integer. If we split this into bytes, we have 8 bytes, and the bytes are ordered exactly how you'd expect them to be. This is big endian, right to left ordering, very, very simple. This is also known as network order because network protocols expect data to be in big endian. Also, a bunch of image formats are also big endian, like JPEG and PNG, as well as some legacy systems and machines are still big endian. But to my knowledge, no modern computers use big endian. Little endian is what almost all modern processors use. Both Intel and ARM are all little endian to my knowledge. Little endian is just reversing the byte order, so the high order bytes are last and the low order bytes are first. Now, an important distinction to be made once again is that endianness only applies to contiguous data. So individual bytes that aren't a part of the same data type are not reversed in little endian. So to make this even more clear, if you have a single byte value, then endianness doesn't affect it. So I tried really hard to make sense of why little endian is used, and the best argument that I got was that little endian makes arithmetic faster, since the least significant byte is at the lowest address, making the byte significance correspond to the address. That kind of makes sense because arithmetic naturally starts with the least significant digit. Like when you add numbers on paper, you start with the ones columns and work your way to the left. For computers, it'd be the same idea but with bytes, since bytes are the smallest addressable unit in memory. It's more efficient to work with them starting at the lowest address instead of the highest address. Think about it. If the computer had to start at the far end of a number, the lower order byte, it would have to skip all the way to the end of the data first, then work its way backwards, which for computers is just silly. For humans, it makes sense because we're used to it, but otherwise it makes no sense. So by starting with the least significant byte at the lowest address, the computer can jump right into the math. However, after thinking about it more, this logic doesn't hold up. The reason that doesn't make sense is because arithmetic is done with registers that load the entire multi-byte value at once. So in theory, there should be no difference at all in performance between big endian and little endian. But something that might be easier is zero extending. If you had to zero extend a big endian data type, then all the bytes would have to be shifted and moved. But with little endian, you just have to append the bytes to the end. Now, a final question I had was, why are network protocols in big endian while all modern processors use little endian? And I'm pretty sure it's just because of backwards compatibility and standards. All other arguments I've heard other than that just don't make any sense. Now, if I missed something, which I probably did, please tell me in the comments because I'm kind of a lot more interested in this now that I've gone over this. Anyways, hopefully you learned something, and all future videos will be announced on my website. So if you want to keep up to date with when I post, that's how you would do it. Thank you for watching as well.